Hey guys, welcome to my channel. I'm LeetCoder, and today we have quite an amazing problem, guys. Very good, guys. So, before we get into it, guys, I want to ask you guys for a favor. I want to ask you guys to go ahead and like and subscribe to the channel if you guys are new here. And yeah, we're in for a good one today. The problem's called binary tree pruning, guys. Right? So it says, guys, given the root of a binary tree, right? Return the same tree where every subtree of the given tree, right, not containing a one has been removed, guys, right? So we said a subtree of a node is the node, right, plus every node that is descendant of the node, guys, right? So they're giving us what is the definition of what the subtree really mean by that, guys, right? So we're very good at them, right? So to pretty much summarize the short problem statement, right, is that so we're given a root, right, of the tree, and then we need to return the same tree, but guys, but by removing um the path, right, the subtrees where there's not a one in them, right? Know what I'm saying? Know what I'm saying? So that's kind of what we need to do. So the examples are going to make it a lot more clear exactly what the ask is for, guys. So let's go ahead and see it, right? So we see we're given 1 0, right? 0 1, right? So we're given this pretty decent looking binary tree, right? So by looking at it, we see that all right, it looks all right. So we see we need to remove, God, right? The path or the subtrees where there's not a one that exists in them, right? So it's just that's why after we delete the subtrees, right, prune it, right? I'm saying that's why it's called binary tree pruning, right? When we do that, we end up with this, guys, right? I'm saying, which only includes subtrees where there's a one in the subtrees, guys. I'm saying there exists a one, right? I'm saying, um, yeah, guys, right? So this zero, obviously, there's no one in that subtree. I'm saying that's why we got rid of it, and then we end up with this one, right? I'm saying this zero, right? There's a one on its right side. That's why we'd end up deleting that zero. I'm saying, because there's a one that exists, right? And a subtree is the node plus all of its children, right? I'm saying, which is important, guys, right? So this example is the kind of similar, guys, right? So from one's perspective, right? I'm saying there's no one on its left side at all, right? So that's why you say, oh, just get rid of that left side. I don't need it, right? Because there's no one, right? I'm saying, because that's what the problem statement says, right? If there's not a one, right, just get rid of it. I'm saying, I'm saying, yeah, that's what prune it, right? So that's what they're saying, and that's where we end up, guys, right? And this zero obviously is the same case as that one, right? We talked about how because there's no one on that path, right? I mean, there's no one on that subtree. You just get rid of it, guys, right? And then this one, guys, is similar. Same logic, guys, right? Uh, from this one's perspective, right? There's no one on its left side, so we just said get rid of it. And this zero, there's no one on its left side, like, so it gets rid of it, right? It can't get rid of itself, guys, because there's a one on its right side. We would get rid of this zero, right? You know what I'm saying? If this was zero, then we would have get rid of it, right? Then the tree would have looked different. It would have only included those four ones, right? I'm saying so the right side would have been empty, right? If that was the case, guys, right? So hopefully by going through this example, you guys kind of understand the problem statement and what's needed to solve this problem, guys, right? You know what I'm saying? So we understand what the ask is, so we have a better understanding of the problem. So how can we solve this problem, guys? What are kind of technique do we need? What kind of logic do we need to solve this problem, guys? Right? This problem is a very good one, guys. Right? Uh, what kind of traversal do we do? Do we know the BFS, DFS, pre-order, post-order, in order? What kind of traversal do we need to solve this, guys? Let's see what's the most logical. Let's just go through a couple of logic. I'm saying and see what we can come up with. I'm saying so. Let's see, guys, right? So we see a 1 0 1, right? So, okay, how do I know to delete my left side or my right side, right? I'm saying, how do I know when to get rid of it, guys, right? So, and how do I know I need to get rid, I'm saying, to let my parent know to get rid of this subtree because this subtree is not good, guys, right? So, we're gonna have to do some controversial, guys. So, all right. So I need to know the answer from my left side. I need to know the answer from my right side, right? Why? Uh, I need to know the answer from my left side, my right side, so I can know should I send a signal to my parent, right? To tell it, hey, yo, there's not a one in there. So therefore, because there's not a one in that subtree, please delete me. Please get rid of me, right? Um, how do I do that, right? You know what I'm saying? So the most intuitive traversal that we can think of right now, guys, since we need to know the answers from our left side and our right side before we make some kind of decision, guys, right? The traversal that comes into mind should be the post-order traversal, guys, right? Where we visit our children first, right? And then we take care of the root, right? So this is exactly what we're going to do, guys. We're gonna pretty much visit our left side and our right side after we visit those kind of the left subtree and all right subtree, right? We get an answer back, right? If they're both null, right, and my value, right, is zero, then I return to my parent and tell it, oh, does not exist a one, right, in this thing, right? But if I don't get a null from both my left and my right, right, then I return myself, right? Because I know there must exist a one, right? Because both of my left side and my right subtree, they're not both null, right? You know what I'm saying? So I need to make sure that I don't get rid of that node, guys, right? So yeah, so let's see how it's gonna work, guys. So pretty much we're gonna do a post order, right? So we go boom, 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 we go to zero. Zero is gonna visit its left side, right? Left side, also its right side, you know what I'm saying? So there's nothing on the left side, nothing on the right side. So it's null, null, right? And also, so the left side is null and the right side is null, right? And the value of that node, right, is not a one, right? So because of that, we could say, cool, this we could mark this whole subtree as being not good, guys, right? It's not what am I saying? It does not contain a one, right? So we send that to our parent and say, yo, no, there does not exist any like no, there's no one in there, right? And then we go there, right? And then this one goes left, goes right, right? No, no, right? It doesn't matter. And then it returns because it's a one, right? You know what I'm saying? So we just return to our parents, yo, there exists a one, right? And that's in your right subtree because I'm a one. You know what I'm saying, even though my children are there's nothing there, right? But I'm a one. From your perspective, there exists a one on your right side. Please don't get rid of me, right? I'm saying so because of that, we're not gonna get rid of this right subtree, guys. All right, and then we do that, and then now zero can make a decision, right? So my left side is null. Okay, cool. I set my left side to null, right? And but I got something coming from my right side, right? So because of that, I'm gonna return to the parent. Say, yo, there exists a one from your right side, right? From your right subtree. So don't set it to null, right? I'm saying don't prune it, right? So make sure you take me into account, right? That's kind of the logic that's going on, guys. So hopefully you guys are able to understand the logic and the thought process that I just talked about. So let's go ahead and quickly code that up real quick and see what we can kind of come up with, guys, right? All right, so this is a very, very fun problem, guys, right? So let's quickly implement that. So we're gonna use a helper function like we normally do with those kind of problems, guys, right? Those truth problems are extremely nice, extremely elegant, right? Requires no kind of a good amount of thinking. But after we think about it and we really, think about it, we kind of come up with the solution. The solutions normally are very, very, they're not like very lengthy, you know what I'm saying? So if the root is null, guys, right? So I'm saying then return, guys, null, right? And then if, guys, right? If it's not null, so let's say no. So what we're gonna do? If the left side, right? We're gonna pretty much say, all right, cool. It's gonna equal to, so we're passing on left side, right? You know what I'm saying? So we're gonna get either a null or not null, you know what I'm saying? Or actual reference, you know what I'm saying? So, and we do the same thing for our right, you know what I'm saying? So, you could have set variables there, say you called it tree node left or tree node right, and then you use them, and then you could have been able to you could have set the values of those root that left, root that right to null after you get those answers. But we could just do it right away, guys. You know what I'm saying, if there's a null, we just set it to null, right? Because there does not exist there's not a one on the left side, right? So right, so we would have set it to null, right? So I just go ahead and do that back there, right? So now after we go left, guys, we go right. We're going to check the root, right? Root that value does not equal to a one, right? So if I'm not a one, right? And my left side, guys, equals to a null, and root that right equals to a null, right? So if they're both null, guys, right? So we return null, guys, right? So if the root value that I'm on right now, right, is not a one, right, and my left side and my right side, they're both null, meaning that you see, we set them to null, right? All right, here, right? If there's not a one in my left subtree or my right subtree, right? So if that's the case, guys, that's the case where the node that we're on is zero, right? And there's no one on my left side, no one on my right side. It will return null, guys, right? And after, guys, what we end up doing, if it's any other case, guys, we can return the root, guys, right, to our parent. So our parent could use us as you know what I'm saying. So if the value is a one, right, they will return the root, right? If the value is a zero, but its left side and the right side are not null at the same time, right? If only one of them is null, right, meaning that uh that there's a one that exists somewhere on my left side or my right side, right? If that's the case, I say, yo, cool, don't delete me, right? Because in this subtree, right, from my parent's perspective, there exists a one, guys, right? I'm saying. And they define why a subtree was got a node plus all every node that descendant of the node, guys, right? So that's what makes it very, very interesting, guys. So let's press run code. See if we pass these small test cases, guys, right? Okay, it looks good. Let's press submit, see if we pass all these test cases. Awesome, guys. We were able to pass all the test cases, guys. So I want to thank you guys for taking the time to watch this video, guys. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next one.